Recall in the previous video we talked about a sequence. And as a reminder, a sequence looks something like this, a sub n, and it's just a list of numbers like a1, a2, a3, and so on. What we're looking at now is a series, and a series is simply just a sum of a sequence. Notice we're taking these terms from the sequence and we're now adding them up, a1 plus a2 plus a3 and so on. We can denote a series using these symbols. This is the capital sigma. You may recall that from Riemann sums. It means we're adding things. We're adding the terms of a sequence from n equals 1 to infinity. Up next, we'll look at a partial sum. If we're looking at the series where we sum from I equals 1 to n of a sub n, up next, if we're given a series I equals 1 to n of a sub n, that is a1 plus a2 plus a3 and so on, if we let Sn denote the nth partial sum, then we have this. S sub n is just the partial sum of this series. If the sequence S sub n is convergent and the limit as n approaches infinity of that partial sum equals s exists as a real number, then the series, the sum of a sub n, is also convergent. That is a1 plus a2 plus a3 plus a4 plus all the way out to an gives us a real number. It is convergent. The number s in this case is called the sum of the series. And if the sequence S sub n is divergent, then the series will also be divergent. In this example, we want to calculate the first 8 terms of the sequence of partial sums correct to 4 decimal places. And we'll also determine whether or not we think it's going to be convergent or divergent. We'll start with S1. S1 is simply the first term in the sequence. That is 1 divided by 1 cubed. We're just plugging 1 in for n, and that will give us 1. S2 is the previous sum plus the next term in the sequence, A2. So we have 1, the previous sum, plus 1 divided by, we're going to plug 2 in for n, giving us 2 cubed. This is 1.125. S3. We have the previous sum, S2, plus A3. And for this, I'm going to start using the calculator. We're going to start getting some decimals, and it'll be easier with a calculator. So we have S2, which was 1.125, and we're going to add 1 divided by 3 to the third. And I'm going to store this in a variable because we want to reuse this number. So I'm going to store or stow this in alpha A. So we get 1.1620. Up next we have S4, that is the previous sum, plus A4. So in the calculator, I'm going to pull up S3, which is the stored value. So alpha A plus A4 is 1 divided by 4 cubed. And again, we will store this so we can use it in the next sum. Here we get 1.777. S5 is S4 plus A5. Again, we'll pull up the previous sum, alpha A plus 1 divided by 5 cubed. Oops, forgot to store it. Stow alpha A. That is roughly 1.1857. S6 is S5 plus A6. Alpha A plus 1 divided by 6 cubed. And I'm going to store that back in A. This time we get 1.1903. S7 is S6 plus A7. Alpha A plus 1 divided by 7 cubed. And store that. We get 1.1932. One more, S8 is the previous sum, S7 plus A8. We'll take the previous sum in A and add 1 divided by 8 cubed. And here we get 1.1952. So looking at these numbers, the partial sums, it looks like they are eventually converging to a value. So we can say that this is convergent. In our next example, we are again calculating the first 8 terms of the partial sum. And we again want to determine whether or not it is convergent or divergent. S1 is sine of 1. We'll again use a calculator to help us with this. Sine of 1, and we'll store that because we need it in the next sum. Here we get roughly 0.8415. S2 is S1 plus A2. So we have the previous alpha A plus, now we're adding sine of 2. We again want to store that. 1.7508. S3 is the previous sum plus A3. Alpha A, pulling up the previous sum, plus sine of 3. 1.8919. I forgot to store that. Store in alpha A. So pulling up the next one, S4 is the previous sum plus A4. Alpha A plus sine of 4. 1.351. S5 is S4 plus A5. Again, I forgot to store that previous one. Alpha A plus sine of 5. I'm going to remember to store it this time. we get 0.1762. S6 is S5 plus A6. Alpha A plus sine of 6. And we will put that in alpha A. This time we get negative 0.1032. S7 is S6 plus A7. Alpha A plus sine of 7. And I'm going to store that this time in A. 0.5537. One more, S8 is S7 plus A8. Alpha A plus sine of 8. And this time we get 1.5431. Notice that there doesn't appear to be any kind of trend like we saw last time. It's not converging to a number. So in this case, this is divergent. Hopefully that makes sense. If you think about the graph of sine, it's oscillating between -1 and +1, and so it's never going to converge to a number. It's going between those -1 and +1 values, making it divergent.